So this is the text. This is a figure from your textbook. Well, you can see that, okay, secondary structure, you see that it is the hydrogen bond. This is an alpha helix. They call this beta pleated sheet. Yes, this is also formed by hydrogen bond. You can see that we have a multiple polypeptide chain line up so that they form like a sheet, but they zigzag at the same time because the hydrogen bond in between them causing them to form zigzag. And then you fold the secondary structure together, then you get a tertiary structure, and after this you get a quaternary structure when you put multiple tertiary structure together. Oh well, they give you a same thing. Well, I already told you about this. So when you put multiple tertiary structure together, you can see that this is 1, 2, 3, 4. You have 4 tertiary structure here for this protein. Oh, I just want to emphasize one thing. Quaternary structure doesn't mean that you must have 4 tertiary structure. If you remember our previous slides, the quaternary structure can have 2 tertiary structure together. As long as you have more than 1 tertiary structure together, then we call this quaternary structure. It doesn't necessarily need to have exactly 4 tertiary structure. You can have 2 tertiary structure, you can have 3 tertiary structure, you can have 4 tertiary structure, you can have 5 tertiary structure. So remember, quaternary structure does not mean that you must have 4 tertiary structure. It just means that you have more than 1 tertiary structure together. So what makes a protein different from each other? 4 factors distinguish one protein from the other protein. For example, number of amino acids. Number of amino acids determines the length of the primary structure, meaning that the length of the polypeptide chain, meaning that the length of the length of the polypeptide chain is the length of the primary structure. So the number of amino acids can be different from protein to protein. And the second one is called the types. Types, what does it mean? For example, you may have one polypeptide chain, maybe they all have the essential amino acid. The other polypeptide chain, you may have all the non-essential amino acid. Or one amino acid chain, you can have a lot of one type of amino acid, meaning that, for example, you may have one polypeptide chain that has a lot of valine, okay? But another polypeptide chain, you may have a lot of glycine. Then, so a polypeptide chain can have a lot of one type of amino acid. And then sequence of amino acid, that is a major one, meaning that if you have a polypeptide chain, then the order of the amino acid can be different. Yeah, most of the time the protein, they have a different sequence of the amino acid. And last but not least, the coiling of the amino acid, meaning that when they form the secondary structure and tertiary structure, how the polypeptide chain is being folded, especially the tertiary structure. It is especially the tertiary structure. The way the tertiary structure fold determine the properties of that protein or the properties of that enzyme. So you may have the same sequence, same type, you may have all these, the first 3 the same, But as long as the protein is folded differently, then you get two different protein because they have two different function. So the 3D structure, the coiling of this amino acid determines the 3D structure of the protein. When they have two different 3D structure, even though the first three are the same, then they have two different function. So the 3D structure determines the function of the protein. So this is a review, the 4 organization level of the protein. You have amino acid. This is the primary structure, the polypeptide chain. And then you have alpha helix or beta pleated sheet. And then you have the tertiary structure. Basically, well, they call it polypeptide chain. Folded, I would say folded polypeptide chain. Folded. My handwriting is really bad. The folded polypeptide chain. Amino acid residual, I personally do not like it. I just call it a polypeptide chain. I prefer to call it a polypeptide chain. Yeah. Polypeptide chain. So this is the folded, tertiary structure is the folded polypeptide chain. Or we should call the primary structure the unfolded. Yeah, unfolded is better, because this is just a strict chain. Unfolded polypeptide chain. And then you have tertiary structure, alpha helix and beta pleated sheet, and then you have the folded tertiary structure, and then assembled unit. Okay, assemble one, this is a good assemble tertiary structure. Then we got the quaternary structure. Okay, let's talk about the function of protein. Protein has a lot of different functions. The first one is the structural protein, meaning that protein gives us a structure, give us shape, give us other structure. It gives us. Let's take a look at some example here. We have keratin, collagen, actin, and myosin. We'll go through all this in the next few slides. So keratin, what is keratin? Keratin makes hair and nails in our body. In human, hair and nails. So your hair, they are basically protein. Your nails, they are basically protein. They're keratin. Where can you find keratin? You can also find keratin on your skin. On your skin, we have a keratin so that the protein can waterproof our skin to minimize water loss from our skin. So that is the another important function of keratin. It prevents our skin from desiccation. And then you have all these baleen plate, horns, reptile scales, bird beaks, feather, talons. Okay, all these, they are non-human. Non-human stuff, I'm not too interested. They are all animals, okay? And well, for horns, okay, if you are Chinese, okay, we Chinese eat the horns of certain animal, like deer horns, because we believe that the deer horns has some medicine value, some kind of medicine value. Yeah. So some of the animals' horn or animals' part, we Chinese use it for Chinese medicine. We believe they have medicinal value. But I only want you to focus on on the human part, human hair, nail, and skins. You can find keratin. And then we can also, okay, for collagen, another structural protein, I want you to memorize that you can find collagen in tendon and ligaments. So what's the differences between tendon and ligaments? If you take anatomy, you will know that tendon connects a muscle to bone, but ligament connects bone to bone. So this is something that it's good to memorize it. So this is muscle and bone. And ligament connects a bone to bone. So the differences, I hope you will understand bone to bone. Okay. And then yes, you can have collagen in skins. So skins has 3 layers. The superficial layer, the outermost layer that you see and touch every day is called epidermis. And then under epidermis you have dermis. You can find collagen in dermis. And you know why we have wrinkle? Because when we are old, when the cell, we call it fibroblast in the dermis, they start to die, or they are no longer active, they stop producing collagen. Fibroblasts are the cells that produce collagen in our dermis layer. So if fibroblasts start to die, or they stop working, or whatever reason, and then you have fewer collagen to produce in your dermis layer, then it makes your skin less elastic. When you have more collagen, then your skin is extremely elastic. When you have less collagen, your skin become less elastic, then you start to have wrinkle. So one way to kill fibroblasts in your dermis is to expose yourself to UV light. Yes, UV light can go through your skin, can go through your epidermis and go into dermis to kill the fibroblast. So in other words, wear your sun blocker, especially we are in Southern California. The sunshine, is very strong. So apply sun blocker to protect the fibroblast in your dermis. And then corneal cartilage. Cartilage and intervertebral disc, they have collagen. Intervertebral disc, they are the cartilage in your vertebral column, in between the vertebra. So they absorb the shock. All cartilage, they absorb the shock to prevent the contact between bone. Because if 2 bones, they hit on each other, it will be extremely painful. You also have collagen in bones. You have collagen in blood vessels, so that and you have gut as well. They said that collagen is the most common type of protein. Well, probably. That I'm not so sure. But if that I'm not so sure, yeah. Probably collagen is the most common type of protein. So actin and myosin.